Dun, 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 dun. Hey everyone, my name is Paulo, this over here is Jiro, and today we're going to do a tutorial on how to make some magic orbs. Also, if you've seen any of the other tutorials I made, this one will look a little different. I'm trying to bring down how much editing this needs. Hopefully this will maintain the quality while also making it a little easier for me to actually do them. We're going to need a few materials for this. I'm going to make some real quick. I'm just going to speed through that, and they'll be available down in the description. Okay, now that we finished that part, let's start by creating, for here we go 3D object, and let's create a quad. And this quad, we're going to title this Magic Orb. And then underneath that quad, we're going to create, we're going to grab this quad over here, which as you can see, it's right here. Let's move it a little further away. Let's give it a little spinneroo so we can sort of see it in front of us. There we go. It is pretty big right now. It's like 1 meter by 1 meter. So probably want that to bring that down to, I don't know, let's make it like 0.15 by 0.15. And then we need to make a material for it. So down here where we have our orb textures, let's right click, create, and then let's make a material. And we're going to make this one the orb. On the shader that we're going to use, let's go to particles, and then you can use standard unlit. This one has an albedo there, so we can just drag our little sphere in there, drag it in, and now we have our material. We just assign it to that. As you can see right now, it's not exactly what we want. This is because the rendering mode is set to opaque, so just change that to additive. Boom. Instant little sparky orb. Now inside of an orb, we create a right click. Let's create another 3D object, and let's make it another quad. And this one we're probably going to want to make it a little bigger, but we'll see in a moment. So let's make the exact same thing we did. We can just duplicate this material that we did for the orb, and this time we call it flare. And then we replace the albedo with our flare material. And then in here, where we have our material, we just drop the flare. There we go. Let's make it a little bigger so that we can actually see it. Maybe let's make it like, I don't know, a 3 and a 3. Okay, maybe that's too big. So take it back. Let's go to a 2. There you go. So there's that. Now I want to add a little bit of life to those to that flare. So I'm going to add a little script to it. This is going to be called auto rotate. And this is very simple. All it does is modify the rotation by the rotation per second that we assigned. In this case, I'm going to assign something like -150. And let's take a look. How's this looking game? It's pretty far, but there you go. You can see we have our spinny guy. As you can see in the floor, we see some squares there. That's because the quad by default comes with shadows on. It also comes with physics on. So as you can see, as I walk towards this spark, I cannot go through it. So those are a couple things we need to disable. So let's select our main one, and over here we have a mesh collider, and let's get rid of it. So remove component, and over here where it says cast shadows, let's turn those off. And let's do the same for our other quad, which by the way I never renamed, so let's just rename it as flare. And same with as the other one, turn shadows off, and let's get rid of the collider. And next, let's add to this magic orb another component, and this is going to be under effects, and this is going to be called trail. And right now you can actually see the effect of trail by just moving this one around. So let's see if I move this. That is our not very subtle trail, which is kind of gigantic at the moment. So the reason for that is because of the width. So we can just grab the width and bring it down, 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 down. So we want, and like maybe like a 0.4. Then you can also right click here and add a second key. And then at the very end, you can make it go all the way to 0. So now when I move it, as you can see, it kind of has like a thin tail at the end. It does last a long time, so we probably want to tweak that's how long this stays alive. Let's change it to like a 1 or something like that. And then we can try it again. And that's a more decent duration for it. It is pretty flat right now, as you can see. Like, it's not not very exciting because it's just a flat thing. And for that, we have this other material over here. So just like we did before, we are gonna create a material for it. So let's duplicate this one. Let's call it trail. And let's replace the texture in there with this other one we made. Then in our trail, we're going to replace the material, which is down here, with this one we just made. Now when we grab the orb and we move it around, you can see it has our material, but you can see a little bit of the holes in there, but it's not particularly interesting. It gets a little more interesting if we change the texture mode from stretch into distribute per segment. So now when we select this magic orb, we move it. That doesn't look particularly better. And, repeat per segment. Sorry, I think repeat per segment is the one I wanted. Maybe, please, no? Yeah, okay, so now you can see it has this little weaving sort of pattern in there as we move around. But it kind of depends on what effect you wanna achieve, but that one looks pretty good to me. So at least it gives it a little more of like a bit of more interesting texture than just the flat trail that it had before. Okay, so now we have that. The next thing we want to do is make sure that it's always looking our way, because right now we can go behind it and then you cannot see it, right? So for that, we're gonna add a little script here. It's going to be a new script, and we're going to call this Billboard. Double click to open it, and it's going to be super simple. All we're going to do is transform.rotation equals camera.main.transform.rotation. You probably want to basically save this into a variable just so you're not checking it every frame, but for now, just for the sake of a quick demo, this is totally fine. So when we run the game now, you can see the little texture here. No matter which angle we turn around, it's always looking front to the camera. So it's spinning, it's looking towards the camera. What next? Well, we want it to chase us. And for that, we're going to add yet another script to the magic orb. And this time we're going to call new script. We're going to call it magic orb. So let's start declaring a public transform. This is going to be target. That's basically whatever we want it to be chasing all the time. And then we're going to declare a vector tree movement. Then over here we're going to do if target. So we have something we're chasing. We're going to determine where do we want to go. So for that we're going to do a vector tree delta, and it's going to be equal to our target dot position minus our own position, which is transform dot position. So that tells us the difference in position between the target and wherever this magic orb is. But we also want to know just the direction, and for that is basically just the same as the delta, except we're gonna normalize it first. So delta dot normalize, that essentially is giving us a direction vector of where do we want to go. And then we're going to do movement is going to equal, for now I'm just going to put it to direction. We're going to change this afterwards, but just for now so we can see how it works, that is fine. And then at the end we're going to do transform dot position plus equals movement times time dot delta time. When I'm back in the game, we select this, and as you can see we have an entry for target, and let's select Ellen, which is our main character. So you can see slowly but surely a little particle is coming to us. So it's very slow and it's very close to the ground because Ellen, the position of Ellen is at her feet, so that doesn't look great. So let's do a couple quick adjustments. The first adjustment is, instead of pointing to Ellen, I'm going to point to this camera look at, which if we look at it, it's essentially on her shoulder blade. So that's a much nicer point for the orbs to go to. So You can point it to wherever you want, but that one works. The other thing I want to change is that right now movement equals direction, which is a normalized vector. That means it's moving at 1 meter per second, which is pretty slow. So let's declare a few things over here. Maybe let's declare a float. Float, call it speed equals start at 0. Then over here we're gonna call float acceleration. Maybe I should spell it properly. Acceleration. And then the acceleration we can set it to whatever we want. Let's set it to maybe like 10 meters per second. And then over here we're gonna say speed plus equals acceleration times time dot delta time. And then over here where we're saying movement equals direction, instead of that we're going to say direction times speed. Okay, here it comes. As you can see, it's pretty fast. It goes pretty nutty once it gets close to us. That's because we don't have a max speed right now, so it's just going to do basically the longer it lasts, the faster it gets, and it starts to travel like crazy. So we should add max speed so that it doesn't go that crazy. So over here we're going to do float, say max speed. Let's set that to like 10. And then over here we can say speed equals mathf dot clamp. Well, actually we can say speed dot min between speed and max speed. So here it comes. Beelines to me, and once it gets, it always keeps on chasing me forever. So we should do something so that once it reaches its destination, it basically destroys itself, because we don't want to be making a ton. But first, so we can experiment, we need to create a creator of orbs so that we can keep generating more so we can test. So that's pretty easy to do. Basically, we're going to grab our magic orb from here, and we're going to pull it into our, and let's put it into this folder since we have that. We can drop it in here, and that's going to be a prefab, so we can actually rename it Magic Orb Prefab. If you haven't worked with prefabs, essentially is like, they're like recipes of how to make things, right? So this prefab has inside of it the orb, the flare, and the trail, and we can just make a ton of copies out of it from it. One thing that's important to keep in mind is that, for example, the target gets wiped because the target right now is part of the level, whereas the prefab is only a recipe, so it doesn't exist yet in the level, if that makes sense. So let's delete this other one that we had over here, and then let's add a new object in here, an empty object, and we're gonna call this Orb Creator. And let's add another script to it, and we're going to call Orb Creator. So in here, let's declare a public game object, and this is going to be the orb prefab. Let's create a little function here. Let's call it void create orb, and then just that can call a game object. This is called go, just to abbreviate, equals instantiate. And then there we pass the orb prefab, so it knows what to create. And then we need to from there grab the magic orb to give it a target. So let's create another one here. Let's call this public transform target. And then over here we can do magic orb equals go dot get component. So we're gonna grab the component that we made, the magic orb, and then we're gonna say orb dot target equals target. So that will allow us to create an orb, but I want to create a bunch of orbs. So over here I'm just gonna say an update. I'll say if input dot get mouse button down. Then I'm just gonna say if at 0 button, which is our left click, So if I press left click, I want to create a bunch of orbs. So I want to say for int I equals 0, I less than 10, and I plus plus. Then over here, I'm going to say create orb. So essentially I'm saying every time I click the mouse, I want to create 10 orbs. So in an orb creator, it asks us for two things. One is a transform, which we know we want to go to this camera look at. And the other is the prefab, which we know it's inside of here. So select that and then magic orb prefab. Let's give it a test. There we go. So those are the orbs. I know it doesn't look like it, but those are 10 orbs. They're just overlapping on top of each other. And the reason they're overlapping is basically they always start with the same conditions. So I want to change that a little bit. So back in our magic orb code, I want to give them an initial movement that is random. And for that in our start, we're going to say movement equals new vector. And then in this vector, we're going to pass in a random dot range from -1 to 1. Let's put F so it knows it's not an int. And then we're going to essentially copy this a couple more times. There you go. So that will give us like a random direction to start on. But let's also spruce it up a little bit by saying movement equals, and then over here we're going to say movement, which is the one we just determined, but we're going to normalize it. The reason for that is that, for example, since this is a random number, it could have rolled 1, 1, 1, which is going to be a bigger vector than 1, 0, 1. So it's going to be really inconsistent if we don't normalize it first. So we normalize it there, and then we want to multiply this by a random speed. So we're going to say random dot range, and this can be whatever we want. I'm going to go from like 2 to 4. But you can tweak it to fit whatever you want. So I'm going to comment this for a moment, and the reason I'm commenting it out is because it will stop the value I'm putting here. And this one right now reflects the direction we want it to travel on, whereas right now I'm just saying this is the initial movement that I want it to have. So if we like how this looks, then we can actually combine the two. So when I click, there you go. You can see they basically are traveling outwards in random directions. So now to combine the two, we uncomment that, and instead of just setting it to that, we're going to make it lerp. So over here we do vector tree dot lerp, and we're going to go from movement to direction dot speed, and then over here we're going to declare, let's call it turn speed times time dot delta time. And for now, let's grab turn speed and let's put it over here. Let's say float turn speed equals, for now, let's just set it to 1. So now when we click, they start going outwards, but then they come towards me. And then as you can see, they keep going. That's because we haven't destroyed them yet, but we'll do that soon. So we can create a bunch, and they always like go outwards and then come to us. So now what we want to do is once the orbs get close to us, we want to destroy them. And there's several ways we can do this. The way we want to do this right now is going to be based on the distance from us to the orb. That is not the most optimal way to do it, because since the orb movement speed is variable and our frame rate is variable, it could happen that it travels so fast that it goes across us. So if that happens, obviously that's a problem. Generally what you want to do to solve those sorts of things is that you want to do from the previous point that it moved to the next one, you want to do a raycast in between to find if it collided with whatever you wanted to do. But that's a little more complicated than I want to do right now for this quick tutorial. So right now we're just going to do by magnitude. Okay, so how do we do that? Well, we have the delta here, so we can easily just say if delta dot magnitude less than, and I'm just going to put an arbitrary number here, 0.35, which basically would be like a third of a meter, then we're going to destroy it. So we can just go destroy and then game object. So when we click and the object comes to us, boop, boop, boop. As you can see, one of them actually got past us, which was exactly the problem I was mentioning earlier. So the other problem is, you see, I'm going to put it in slow motion so you can see it. but as soon as they touch, the trails disappear, which doesn't look nice at all. So, oh, I gotta remove the shadows, I forgot. Anyway, so as soon as they touch me, you can see the entire trails disappear. That doesn't look great, so we definitely wanna give it a little more polish there. So what we can do for that is use Do Tween. If you're curious about how Do Tween is used, you can check out my previous tutorial on interpolations, but for now we can just do it using dg.twinning. Then over here we're gonna get an access to the trail. So let's say public trail renderer, and this is gonna be called trail. And then when we get to this part over here, we are gonna say trail dot do time. As you remember, when we were setting up the trail, we set up a time that we wanted it to last. So you can actually then just interpolate that one down to 0 over, let's say, 0.3 seconds or something like that. So just something quick. So let's say half a second, and then do onComplete equals, and onComplete is a delegate. I also explained a little bit of that on that tutorial. And delegate is essentially a function that gets called, a function you can declare to be called on a certain event. So in this case, once it completes this this tween, do that and then destroy it. By shortening the time of the trail, basically we'll shorten the trail itself. Now, one problem we'll have with this is that basically, since this is running in the update, that means we'll keep on going into this loop over and over again, which obviously we don't want to do. So over here, we can just simply say target equals null. And then when it travels, so you can see it actually destroyed them, but the problem is we didn't see it because it kept traveling. You know, it goes there and goes that. So we basically need to slow it down as well. So to slow it down, we can do two versions. So over here, we're just going to do movement equals vector 3.0. So that will stop as soon as it touches us. Bring them on, and then once they get close, bloop, 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 bloop. As you can see, they stop as soon as they touch us. Instead of just fully stopping it, we can also just change this to be delta, which is basically the distance from where we are currently to where we want to be. With this, since we're moving by movement per second, and we only have half a second to get to our destination, we can multiply this by 2 to make sure we always get to the center. So you can see once they kind of touch me, I'm going to activate the slow motion so you can see it. Once they touch me, they all sort of kind of go towards the center of me. See this one? There you go. So they change directions as soon as they touch me, which I think looks pretty okay. Other thing we can add is, for example, we could add access here to public mesh renderer, and let's grab the orb. And while we're at it, might as well grab the flares, just so that we have both. Although right now I'm just gonna use the orb initially. And then down here where we're doing this, we can say orb dot transform dot do scale. So basically change the scale of the orb once we want to destroy it, and then just change it to essentially vector 3.0, and do that over 0.5 seconds. So we open our prefab, and over here we have a couple new slots, one for the orb, so just pull it there, and one for the flare, pull it there. And while we're here, might as well select the trail and turn off shadows. And when we click, you see once they touch, they kind of just shrink. Bloop, bloop. They look more like they're being absorbed. One thing I just realized I forgot to do is in our Orb Creator, I forgot to do Orb dot transform dot position equals transform dot position. Otherwise, it just keeps the original position of the orb. So I'm going to move the creator a little bit up just so that we can test if that actually had effect. And when I click, they come from the top. Okay, I was thinking that it looked a little weird. So anyways, right now when you can see once they get close to us, they kind of shrink into us. As you can see, still several of them still misses, and that's because of the turn speed. The turn speed right now is pretty slow, but I don't want to make it too fast, and I'll show you why. So if I go back to my magic orb, right now the turn speed is set to 1, which is very slow. I'm gonna go crazy and I'm just gonna set it to 10, just so I can show you the part that I don't like about turn speed being really high. So with turn speed really high, as you can see, now they all sort of come together because they turn super fast. And I don't like that. I really like the initial sort of like explosion outwards and then they travel to you. So what I want to do is, instead of just increase the turn speed, I want to make it so turn speed increases over time, so that when it starts, turn speed is really low, but over time it becomes higher. So I can just set turn speed to 0 there, and then down here I can say turn speed plus equals, and then I'm going to say maybe like 3 times time dot delta time. So that means that turn speed is going to start at 0, but by the end of the first second, it's going to be up to 3. By the end of the second it's going to be up to 6, so on and so forth. So the longer it lasts, the faster it turns. Now you can see it still does the explosion, but then eventually it turns to us, and now they're not missing as much because they can actually turn and get to us. So the last thing we're going to do is actually add the ability to change the color on them. But before we do, if you ever want to watch more of my content, you can come to twitch.tv/PabloPoon. I'm there on Monday. Why do I always say Mondays? Anyways, I'm on Twitch. Come hang out if you want to. I'll see you there. So to set the color, we're going to create a new function here. I'm going to call it public void set color. I'm going to pass in a parameter to it, and that's going to be a color, as you can imagine. P color, and then in here we're going to say trail dot start color equals P color, and trail dot end color equals P color. For now, I'm going to set the color to all the things, but I'm going to show you after the reason. I generally don't like to do it to all, but I'm going to start with all so that we can see it. So we do that, then we also have the orb, right? We got the orb dot, and then material dot color equals P color, and we also have the flares, materials dot color equals P color. And now in our orb creator, we're going to declare here color random color. You can make this from a set of colors if you prefer. Right now it's just for the ease of making it quickly. I'm just going to say random dot color HSB, which is a color that will be randomized, and basically it'll take 6 parameters. The first 2 are the hue, which decide the color, so I'm going to go from 0 to 1. The second set of values are for saturation, which I want to go really high, so I want to go from 1 to 1, so I want it fully saturated. And last is the value. This is how much luminosity it has. I'm going to go from like a 0.75f to, actually I'm going to keep both at 0.75f. I don't really like when it goes like fully lit, because since it's additive, it just kind of blows out the color. And then I obviously need to pass the color down to the orb, so let's add a new parameter here. Let's call it just like we did before, P color. And over here we can say orb dot set color P color. As you can see, this one's complaining because it doesn't have a color, so let's just do random color in there. Let's save our script. So there you go, yellow, pink. You know, every time we click, we get different colors. Now, the reason I don't love this version is because they just like the same color, so it doesn't look that interesting to me when the whole thing is the same color. So I much prefer to change it up a little bit. And to do that under magic orb, maybe we don't change the orb, so that way the orb remains white, and maybe don't change the end of the color. The end of the color you can barely notice because the trail kind of becomes small, but I think makes it look a little more interesting. So now when we started, you can see it, let me slow it down. You can see the center is white now, and the tails of the trails are white. I don't know, I feel like it gives it a mirror. You can still see the color, you can still see that those are blue, but it makes it feel a little more incandescent in my opinion. And I don't know, I just like it more. Also with the slow motion and the colors, we can go full on Peggle. Dun, 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 dun. Dun 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 dun. So you can have a lot of fun with this. You can use them like they do in God of War to give you like health or energy. You can use them even as projectiles to attack enemies. You can make them the XP little blobs that come out of enemies when you defeat them. You can do all sorts of things. One recommendation I would give you if you're going to use this in a proper project is you probably want to do a pool of them. So basically make like 30 of them, and then as you need them, just grab one, use it, and then recycle it. That way you're not creating memory fragmentation from creating a whole bunch of them all the time. But obviously that's a more advanced subject. I hope you learned something. I hope you had a good time. If you did, please remember to subscribe and like the video, and I'll see you on the next one. Adios.
Well, thanks for stopping by. Don't forget to like, subscribe, and hit the bell to be notified when new videos come out. Thanks for watching.